So good morning to all of you once again in our lecture series on quantum mechanics. So in our last class we have been discussed some important questions, and today also we are going to solve the questions whatever I given in our last class. So last class we have been done important questions, this one, and the most important I can say that is this like this one will be the one of the important question, x square and px square, x cap square px cap square. So up to 9 questions we have been solved in our last class, and today I am going to be discuss whatever the question I given in the last class. So I somewhat I given the hints that how you are going to be solve the questions. So the 10th question whatever I given, that is prove that this one, okay, the so called Jacobi identity. That is a cap b cap c cap commutation, whole commutation, plus b cap c cap a cap commutation over the whole commutation, plus c cap a cap b cap commutation, and whole commutation should have to be 0, and this will be known as Jacobi identity. Sometimes the question will be asked that verify the Jacobi identity. Maybe this statement is not going to be asked in the exam, only this statement will be asked. So you have to remember this statement and you have to be solve as accordingly. Okay. So now first we have to consider this term, a cap b cap c cap, the whole commutation. So here a cap will be here and b cap c cap commutation will be nothing but b cap c cap minus c cap b cap whole commutation. So it will be a cap b cap c cap minus a cap c cap b cap. Okay. So this term can be written as the b cap will be move this side and c cap move will be this side, whatever we have been discussed in our last video and or last video questions. Several questions this type we have been discussed. See, first I have to take a cap this side, sorry, b cap. Here b cap I have to take the left, the rest operators is a cap c cap will be here, then c cap will be moved towards the right, plus the rest operators are a cap b cap will be there, and c cap moved towards this side, c cap. Okay, so this can be written as this one. Okay, likewise this can be written as c cap a cap b cap plus a cap c cap into b cap. So as it is minus is there, minus, so it will be minus and this will be minus. Likewise b cap c cap a cap, this term can be written as c cap c, from this to this, what it is written, b cap came to the initial, then a cap c cap, then c cap gone to the right side and a cap b cap, like that. This format we have to be consider over here. The c cap will be go outside and b cap c cap b cap a cap commutation, plus a cap will be move this side and b cap c cap will be there, b cap c cap commutation a cap, minus just reverse of this term and reverse of this term. That means here b cap c cap, a cap is there, the a cap will be moved to this side, minus a cap b cap c cap, see, a cap b cap c cap moves to this side, c cap a cap b cap. See, this is not the formula that I am going to say. This by segregating these two terms we got this term. So as this term, whatever the terms we got like this, similarly or similar way we are trying to write this term. Okay, so this term will be here, we can write a cap will be beginning and b cap c cap, so it will be minus a cap b cap c cap commutation, and then here c cap will be moved towards the front this side, so it will be b cap a cap minus b cap a cap c cap. Similarly, c cap a cap b cap whole commutation can be written as this one. See, this can be done by this way, okay, by step. So with step by step we done this one, so similarly we can write for this one equal to this one, and this one will be this one. Okay, now we have to add the terms, simple. So as per the question, this plus this plus this, that is this plus this plus this is the question whatever we given to us. So this term is segregated by this much, so that these 4 terms I have to write over here. This will be C b cap commutation of a cap c cap, b cap commutation of a cap c cap. So another 3 terms I have written over here. Next, instead of b cap and c cap a cap, I have to write these 4 terms over here. Okay, next for this one I have to write the 4 terms over here. So here you can see that b cap a cap c cap, okay, b cap a cap c cap. Here another term is here, see, this is minus b cap c cap a cap. We know that very well that if a cap b cap will be there, it will be equal to minus b cap a cap. We know this one. So same rule we are going to be apply over here. This is c cap a cap commutation will be minus a cap c cap commutation. So this will be minus a cap c cap commutation, this much will be minus a cap c cap commutation, b cap will be here, so this is minus, so it will be plus. So this is the one term, b cap a cap a b cap c a cap c cap commutation. Here also we are going to get plus b cap a cap c cap commutation. So only for that I can write 2 into b cap a cap c cap. Okay, similarly we can get c a cap b cap commutation into c cap. See, exactly same here you can get, this is minus b cap a cap. If I am going to write a cap b cap, then it will be plus a cap b cap c cap. So here a cap b cap c cap, I have to write the 2 terms I got, so it will be 2 into a cap b cap c cap. Okay, so here one thing I am going to be suggest you, maybe sometimes it will be unconsciously you can do the mistake. Suppose it will be like this, a cap b cap c cap. Okay, suppose one term is this one, a cap b cap and a cap b cap c cap. Another term will be c cap a cap b cap will be there, suppose. So these 2 terms are not equal. Okay, these 2 terms are not equal because here a cap b cap commutation, then c cap operator is there, but here c cap is on first initial, then a cap b cap commutation. So these 2 are not equal. That means you are not going to write that 2 c cap a cap b cap. You could not write here. So we have to follow the order or the arrangement or the serial of the operators are operated. Okay, so whenever we have to found c cap a cap b cap, another term plus c cap a cap b cap, then it will be add and it will be 2 c cap a cap b cap. Okay, suppose it will be minus, means it will be 0. That's it. So order or arrangement or seriality of the operator here in the quantum mechanics is very, very important. So you should not, or you could not change the order, okay, without any what cause or any properties. Okay, see here you can change the order, means it will be minus. Suppose A cap and C cap, then it has to be minus, like that. So if you followed the properties, then you can change, or without any followed properties, then you cannot arbitrarily, you cannot be right, or you cannot be add and subtract, or you cannot change the order of the operator. So these things you should have to be conscious whenever you are going to do the problems regarding commutation specially. Okay, so similarly we can get 2C cap, B cap, A cap, 2 B cap, C cap commutation, A cap, and 2 A cap, C cap, B cap, 2 C cap, A cap, B cap. You can find that each terms have another term will be there, then it will be added, then it will be add together, and they are going to be like this. So 1 2 3 4 5 6 terms we are going to be get from these terms, okay, from these 12 terms. So now we can take 2 outside. Here you can see 2 outside, and all the terms will be in the curly bracket. Okay, now 2 here you can see this can be written as this. Got it? See, B cap, A cap, C commutation plus A cap, B cap, C. This is commutation. That means B over here means it will be segregated as this one, or these two terms collectively can be written as this one. So here A cap, B cap, C cap, when you are going to be segregated or separated, then it will be B cap will be moved towards this side, it will be B cap, A cap, C cap, plus C cap will be moved towards right side, then it will be A cap, B cap, C cap. So this term, these two terms with added or following the properties, it can be written as this one. Likewise, these two terms can be written as this one. Likewise, these two terms can be written as this one. So hence here now we can put the simple commutation rule, that is A cap, B cap, C cap, A cap, B cap, C cap minus B cap, C cap, A cap. For this one, this is B cap, C cap, A cap minus C cap, A cap, B cap. Here C cap, A cap, B cap minus A cap, B cap, C cap. So each and every term have another negative term will be there, it will be cancelled out. See, A cap, B cap, C cap, whatever the order, same order minus A cap, B cap, C cap will be there. So it will be cancelled out. Here B cap, C cap, A cap minus is there, here plus B cap, C cap, A cap plus is there, will be cancelled out. Then C cap, A cap, B cap plus C cap, A cap, B cap plus minus plus going to be cancelled out. These questions also can be solved by the another method, that from this 12 terms we are going to be write separately or segregatedly in this way, that see here AC commutation means it can be written as B cap into A cap, C cap minus C cap, A cap. Okay, AC commutation can be written as this A cap, C cap can be written as A cap, C cap minus C cap, A cap. So B, when it will be multiplied over here, it will be how much? It will be B cap, A cap, C cap, B cap, A cap, C cap minus B cap, C cap, A cap, B cap, C cap, A cap. Okay. Similarly, all the terms we are going to be write. See here this will be, this commutation will be A cap, B cap minus B cap, A cap. So C, when it will be multiplied, then it will be A cap, B cap into C cap minus B cap A cap into C cap. B cap A cap into C cap. The order should have to be followed. You could not write C cap over here, or you could not write C cap at the middle. In which way the operator are orderly written, in that way you have to be right. So if all the terms you are going to be segregate, or you are going to be remove the commutation bracket and generalized way whenever you are going to write, then you are going to get 24 terms, and each have its opposite term. See, B cap, A cap, C cap, here one positive is there, you can search B cap, A cap, C cap, another one, so this will be cancelled out. So like that, each and every term have one another negative term will be there, and it will be 0. So this question can be done in these two ways, as your wish you can follow. Now second question is that x d by dx, so that commutation of x d by dx will be equal to -1. Okay, so as we have been considered to find out the commutation of component of position and momentum, in our last class we have been considered arbitrary function. I am going to show you that whenever we have been discussed about commutation relation between operators of component of R, at that time we have been considered an arbitrary function. Then we solved traditionally, and we found that the value will be 0 for position components, and for the momentum components they are also commute with each other. But position and momentum, they have followed one rule, that will be Ri Pj or Ri Pi will be equal to IH cross, and others will be 0. These things have been solved by considering an arbitrary function. Likewise here, as we have two operators, so here we have to consider an arbitrary function psi x. So when this commutation is going to be operate over psi x, it will be this commutation, inside this it will be x dx minus dxx. Okay, so this two x dx will be operator, d by dx of x will be operator, is going to be operate separately over psi. What will be the x d by dx on psi, d psi by dx, okay, minus d by dx of x psi, d by dx of x psi. So this can be so here x d psi by dx. So here you can use the product rule. It will be x d psi by dx minus psi. So this term is going to be cancelled out. So x d by dx psi will be equal to minus psi. So hence x d by dx of commutation will be equal to -1. Similarly, we are going to be prove this one. So considering the arbitrary function, it will be arbitrary function psi, it will be xq x dx minus x d by dx of xq. So this whole will be operated over psi. This whole will be operated over psi. So it will be xq x to the power 4 d psi by dx minus x d by dx of xq into psi. Here we are going to use the product rule, differentiation product rule. This will be x to the power 4 d psi by dx will be there, and it will be minus x, it will be xq d psi by dx minus x, xq derivative will be 3x square psi. So this term will be opposite and equal, is going to be cancelled out, and this term is nothing but minus 3x square psi. Okay, so hence xq x dx over psi is nothing but is equal to minus 3x square psi. Hence the commutation of xq x dx will be equal to minus 3x square. Okay, now this is another question, very easy question that maybe you done this one. So here it is px cap h cap, we have to prove this one, where Hamiltonian operator is this one. So here we have to write, instead of h cap we have to write this one, px cap px cap square by 2m plus 1 by 2m omega square x cap square. So here plus will be there, it can be written as px cap comma px cap by 2m commutation plus px cap, and this is half m omega square x cap square commutation. So we know that the operator itself commute with each other. So if we have to take 1 by 2m outside, px cap commute with px cap, it will be 0, and it will be the constant can we go outside 1 by 2m omega square gone outside, and in bracket or in commutation bracket it will be px cap x cap square. Okay. So here this can be written as minus. So here minus, this can be written as minus x cap square px cap. Same I have been written here. So this is plus. If I will be change the order, then it will be minus 1 by 2m omega square x cap square px cap. This will be comma over here. Comma and cap, carefully you have to be observe and you have to be put. Okay, comma and cap. So here x cap square px cap. We know that in our previous problem, we know that x cap square px cap commutation is nothing but 2ih cross x cap. So at last we found this one. So this can be also solved by traditionally x cap into x cap, this x cap into x cap px cap. Then you have to write the things, you have to take this one, left side, right side. Traditionally also you can be solve this one, that this will be this one. Okay, so hence it has been proved. Now this is a very simple question, that if a cap b cap commutation will be equal to 1, then so that a cap b cap square commutation will be equal to 2 b cap. Very simple question. So here can be written as a cap b cap square, or can be written as a cap b cap into b cap, comma either. Okay, so here b will be go this side, will be written as b cap into commutation of a cap b cap plus a cap b cap, another b will be go this side, so b cap. Okay, we know that b cap a cap b cap will be equal to 1, so this value will be equal to 1, this value will be equal to 1, so b cap plus b cap will be 2 b cap. So it has been proved. Okay, now another important question, sometimes it will be asked as 8 marks directly, and also somewhat tricky question that you have to be practice and you have to be remember for your exam, these things. Okay, this question can be asked as a long question, this question, and another question, another 3 questions is there, 14 question, 15 and 16. These 3 questions will be asked as 5 to 6 marks in your exam. Basically for question number 14 and question number 16. Okay, carefully you have to watch. Here we have to show that e to the power a cap into b cap, e to the power a cap into b cap, e to the power a cap b cap into e to the power minus a cap will be b cap plus a cap b cap commutation plus 1 by 2 factorial a cap b cap commutation, whole commutation, plus 1 by 3 a cap commutation of a cap b cap, like that it has been written. Okay, somewhat interesting. Consider for that, to solve this question, we have to consider a function fy as e to the power f lambda is equal to e to the power lambda a cap b cap e to the power minus lambda a cap. This function we have been considered here. So now the Taylor series of fy lambda about lambda 0 will be written as how, what that will be f lambda will be equal to f0 plus lambda by 1 factorial f dash 0 plus lambda square by 2 factorial f double dash 0 and so on. Let this is equation number 1. This is equation number 1. So now f0, f function we have been taken as this much. So f0 will be b cap. here e to the power 0, e to the power 0 equal to 1, 1, so b cap. So now we have to consider f dash lambda, f dash lambda, f double dash lambda. Okay, f dash lambda will be nothing but del f by del lambda. Okay, del f lambda by del lambda, this is the function of lambda. Okay, no problem. So df lambda by d lambda. So here f is nothing but, f lambda is nothing but e to the power lambda a cap b cap e to the minus lambda a cap. That these things derivative we are going to be do with respect to lambda. First product rule, simple we are going to be apply here. This is e to the power first term is there, e to the power lambda a cap. So it will be, when it will be derivative with lambda, then a cap will be come over here, e to the power lambda a cap, b cap e to the minus lambda a cap, minus e to the power lambda a cap b cap, and derivative of this one will be a cap lambda a cap, it will be with respect to, if we are going to derivative this one with respect to lambda, it will be a cap e to the lambda a cap. So a cap for this function, a cap is a constant, so a cap can be written over here or over here, no problem. But a cap could not be written over here because here it is a already one operator is there. So a cap can be written over here or here, no problem, but a cap could not be written over here. So I have been written a cap over here. Okay, for some next step purposes, next step we have to arrange sequentially. I have been written here. So what we found, a cap is there, this much is nothing but our f lambda, sorry, this much is nothing but our f lambda. I have been substituted over here, and this much is nothing but again f lambda. Okay, so I have been substituted f lambda a cap. So this a cap f lambda minus f lambda a cap can be written as in this format, commutation of a cap f lambda. Okay, now f dash 0 will be a cap f of 0. See, f dash lambda is nothing but this one, f dash 0 will be a cap f of 0, right? F of 0 we found that b cap. Okay, so it will be a cap b cap commutation. Okay, now we have to consider double derivative of function lambda f lambda, that is del square f by del lambda square. So first derivative answer we found this one, its another second derivative, it will be a cap del f lambda by del lambda minus del f lambda by del lambda into a cap. Okay, because here a cap and a cap is constant with respect to d lambda when it will going to be derivative. So here a cap will be there, d f lambda by d lambda minus d f lambda by d lambda and a cap. Okay, so this can be written as in your commutation format. This will be, see, a cap this one minus this d f lambda by d lambda a cap, it can be written as commutation of a cap df by d lambda. Okay, so df by d lambda, see, df by d lambda is nothing but a cap f lambda. These things I am going to be put over here. So what I am going to write, a cap will be here, so df by d lambda is nothing but this much. I am going to put this over here, that means a cap comma a cap commutation of f lambda whole commutation. Got it? See, f double dash is found that this one, del f by del lambda we found is this much. So instead of del f by del lambda, I am going to just put this one over here, then it will be this one. this one a cap f lambda. Okay, now f double dash 0 will be how much? It will be a cap f of 0. Okay, f of 0 we know that it is b cap. I am going to be put over here, instead of f of 0 will be b cap. So a cap b cap, commutation. Okay, similarly f triple dash 0 will be equal to a cap bracket commutation bracket a cap commutation bracket a cap b cap, like this. So f iv0 like that we can write. Okay, now equation number 1, this equation number 1 will be, just we have to substitute the value of f0, f dash 0, f double dash 0. What we are going to get? We are going to get that and the left hand side is how much? Left hand side is f lambda, that is e to the power lambda a cap b cap e to the power lambda a cap. So left hand side it will be written as e to the power lambda a cap b cap e to the power minus lambda a cap. Okay, the right hand side will be f0. Okay, f0 is nothing but how much? B cap. Okay, so it will be b cap. Okay, f dash 0 is a cap b cap commutation, so it will be lambda by 1 factorial f dash 0 is nothing but a cap b cap commutation, a cap b cap commutation, plus lambda square by 2 factorial f double dash 0. F double dash 0 how much we got? F double dash 0 we got a cap commutation of a cap b cap whole commutation. Same thing I am going to write lambda square by 2 factorial a cap commutation of a cap b cap whole commutation, like that. The next term will be lambda q by 3 factorial and this much, and so on. Okay, for lambda is equal to 1, to prove whatever the question we have here, lambda is equal to 1. If I am going to put the lambda equal to 1, then left hand side is going to be satisfied. So by putting lambda is equal to 1, e to the power a cap b cap e to the power minus f cap, and the right hand side also matched with our question. So hence it has been proved. So this question you have to be practice and you have to be remember for your exam purposes. Okay, next question is very simple, that is it is if a cap b cap commutation is equal to r b cap, where r is a number or the so called constant, then prove that e to the power a cap b cap e to the power minus a cap will be equal to e to the power r b cap. Okay, just we have to put the results in our previous result from the whatever we have been discussed for this question. Okay, from the previous question we found that this value is nothing but this much, right? Now we have to just put a cap b cap commutation as r b cap. So wherever a cap b cap commutation, I am going to be write r b cap. So here we have to put r b cap, here we can put r b cap. Okay, so here it is given that a cap b cap is r b cap, we are going to be just substitute. So hence left hand side as usual it will be there, so it will be b cap, and instead of a cap b cap commutation I am going to write r b cap 1 by 2 factorial, it will be a cap b cap commutation will be r b cap plus 1 by 3 cap. Here it will be a cap will be there, here a cap b cap commutation will be written as r b cap. Okay, now here b cap r b cap will be here, r is the constant, can be taken over here, 1 by 2 factorial r a cap b cap plus 1 by 3 factorial, r can be taken outside, r it will be a cap. See here 1 r has been taken this side, this one, this r, when it will be taken outside, this one r, again it will be a cap b cap commutation can be written as r b cap. So hence whatever the result, next step, what we can get, b cap plus r b cap plus 1 by 2 factorial r square b cap, because here a cap b cap commutation will be again r b cap. So r b cap, here is another one r will be there. So r square b cap plus 1 by 3 factorial, here it will be r square, again a cap b cap will be r b cap r cube b cap. Okay, so we found that this much b cap. Okay, this is nothing but e to the power r. This expansion is nothing but e to the power, this expansion is nothing but e to the power r b cap. So hence we have been proved whatever it has been given in our question. Next question is very much important as for your exam concern, university exam. Okay, so this is a cap b cap are two operators, both of which commute with their commutators. A cap b cap prove that e to the power a cap into e to the power b cap is equal to e to the power a cap plus b cap plus 1 by 2 a cap b cap commutation. This whole term is exponent of okay, exponent of this whole term. Okay, so whatever the question it has been given, both a cap and b cap are commutes with their commutator. Their commutator is a cap, b cap, this is the a cap b cap commutation. So a cap is separately commute with this one, b cap also separately commute with this one. So it can be written as a cap commute with their commutator, means a cap b cap commutator will be equal to 0. That implies it will be this one. This type of things we have been discussed previously. So hence b cap commute with a cap b cap commutation will be equal to 0. It will be this one. Okay, so here let consider f lambda is a function which will be e to the power lambda a cap into e to the power lambda b cap. Okay, so df lambda by d lambda will be a cap e to the power lambda a cap into e to the power lambda b cap plus e to the power lambda a cap. See, product rule I am going to be used. First I have to derivative this one, plus this will be here, and the derivative of this one, it will be b cap e to the lambda b cap. Okay, so it can be written as a cap e to the lambda a cap into e to the lambda b cap is nothing but what, f lambda. F lambda I have been written over here, e to the lambda a cap, b cap will be here. I have been multiplied one term e to the minus lambda a cap into another term also I have been multiplied e to the plus, this is plus, okay, this is plus lambda a cap. So this term is going to be added and it will be 1. So instead of 1 I have been written here that e to the power lambda minus lambda a cap into e to the power plus lambda a cap, and the term e to the power lambda b cap will be here. Okay, so this is nothing but this two term will be equal to 1. Instead of 1 I have been written this one. So here a cap f lambda will be as usual, it will be written over here, plus e to the power lambda a cap, b cap will be here. So e to the power minus e to the power plus lambda a cap e to the power into e to the power lambda b cap is nothing but f of lambda. So this two term, instead of this two term I can write f of lambda, and e to the power minus lambda a cap will be written over here. Okay, so now f of lambda is going to be, can be taken outside, and the inside in the bracket it can be written as a cap plus e to the power lambda a cap b cap e to the power minus lambda a cap into f of lambda. Okay, so a cap will be here. See, this value in our previous question, this value is how much we have been found. See, in our previous question, e to the lambda a cap b cap e to the minus lambda a cap, we have been found this one. Just I have to put this much over there. So instead of e to the lambda a cap b cap e to the minus lambda a cap, I have to write the result of the previous is this one, and f of lambda will be here. Okay. Now that implies d f lambda by d lambda is equal to a cap, b cap will be here, lambda by 1 factorial a cap b cap, and after all the terms will be equal to 0. Why? Because see a cap b cap a cap commutation with their commutator will be equal to 0. That means see a cap b cap whole commutation will be 0. So here this term will be how much? This term will be 0. Similarly, the higher order terms will become with this type of terms. So higher order terms, whatever we are going to be consider, that terms will be contains this type of commutator terms. So these terms is going to be cancelled out. So how much we got? A cap will be there, b cap will be there, lambda by 1 factorial, a cap b cap, and f lambda is here. F lambda I have been written over here. Okay. So d f lambda by here f lambda I have been taken here this side to the denominator, and d lambda I have been taken up to this side, cross multiplication. So d f lambda by f lambda, and this much term a cap b cap lambda a cap b cap commutation d lambda. Now integrate both the side. What we are going to get? ln f lambda a cap b cap lambda plus lambda square by 2 a cap b cap commutation plus ln n is a constant. So ln n, if I am going to take to the left side, it will be ln f lambda by n a cap plus b cap lambda plus lambda square by 2 commutation of these two operators. So now f lambda will be exponent of f lambda will be n into, here n is there, okay, n into exponent of this whole, that is a cap b cap lambda plus lambda square by 2 a cap b cap commutation. Okay. Now for lambda is equal to 0, if we are going to put lambda equal to 0, then left hand side this c, if lambda equal to, we are going to put the lambda over here, f lambda is how much? F lambda is 1. So f lambda will be equal to 1, and this side lambda equal to 0, if we are going to put also this whole term exponent term will be 0, that means n is nothing but equal to 1. So hence f lambda can be written as e to the power this much, okay, this much. Okay, for lambda equal to 1, so as per the question we have e to the power a cap into e to the power b cap will be this much. So here f lambda we have been considered that e to the power lambda a cap, e to the power lambda b cap. So considering lambda equal to 1, so it will e to the power a cap into e to the power b cap will be the answer, that is exponent of this one, means e to the power this much term is there. So this is proved. So today class is this much. So go through this video. Wherever you want, you can pause the video and you can write the note, and where you found any doubt, you can contact with me and we are going to be discuss. Okay. So thank you so much for watching this video. Thank you.